In this learning guide, we're going to take a look at probability. Here's a very simple probability question. It says, what is the probability of rolling a die and getting a 4? So if I picked a die up and a 6-sided die, and I rolled it on a table, what would be the chance that I would get a 4, or that a 4 would show up? I think you would probably agree that it's 1/6. Why do we say it's 1/6? Well, if you remember back, probability can always be determined by placing in the numerator the number of favorable outcomes. Ooh, that's not really going to fit. The number of favorable outcomes goes in the numerator, so I wanted to get a 4. There's only one 4 on the die. And down here is the total possible outcomes. So we can always determine the probability of a simple event by writing the number of favorable outcomes divided by the total possible outcomes. Let's look at another example. What is the probability of drawing a face card out of the standard deck of 52? Well, we need to know how many face cards there are in the deck. There's a king, queen, and a jack for each of the 4 suits, so there are 12 face cards. Out of the 52 cards that make up the deck. So the probability of getting a face card would be 12 out of 52. Now this of course reduces. We can divide this by 2 to get 6 out of 26. And we can divide it by 2 again to reduce our fraction to 3 out of 13. So the probability of drawing a face card, 3 out of 13, came from 12 favorable outcomes, 12 face cards, divided by 52, the total possible outcomes. Sometimes when we're working with probability, we will want to list what we call the sample space of the events. And the sample space is simply a list of all the outcomes. Let's suppose I'm going to roll 2 dice. The first die that I roll, I could roll either a 1, 2, 3, 4, 5, or 6. The second die, I could also either get a 1, 2, 3, 4, 5, or 6. So I could make a little chart. So I could get a 1, 1. I could roll a 1, 2, I could roll a 1, 3, a 1, 4, a 1, 5, a 1, 6, or a 2, 1, and so on until I have my table complete like so. So in here represents all the different outcomes I could get if I rolled 2 dice. The first number would be the result of the first die that I rolled, and the second number would be the result of the second die that I rolled. So I think we can see here that we've got a 6 by 6 grid, so the total possible outcomes would be 36. So 36 different outcomes if I rolled 2 dice, 2 standard 6-sided dice once. Now I might ask the question, what is the probability that if I rolled those 2 dice and then added up the results, so added the 2 numbers, what would be the probability that the sum of those 2 numbers is greater than 8? Well, from my sample space that I've got here, I can simply go and circle all of the ones where when I add them together, I would get an answer more than 8. So if I looked at this one, 3 plus 2 is only 5. So I'm not going to consider that, but here's one. 3 plus 6 is 9. 4 plus 5 is 9. 9, 9, 10, 10, 10, 11, 11, and 12. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 favorable outcomes out of 36. So the probability of obtaining a sum, when you roll a die twice, a sum that is greater than 8, so in other words 9 or more, would be 10 out of 36, which reduces to 5 out of 18. So sample space is simply you listing all of the outcomes that are possible in the experiment. And once we have the sample space, it can be easy to find probabilities by circling the ones that are favorable and saying there's this many favorable divided by the total. Now in that last example we looked at, we determined that when we rolled 2 dice, the probability of getting a sum greater than 8 was 10 out of 36, which we reduced to 5 out of 18. Notice the notation here. This is a nice short way of writing probabilities. You write P for probability in bracket inside the probability that we want. So the probability that the sum was greater than 8 equaled 5 out of 18. What if I ask this? What is the probability that the sum is less than or equal to 8? Well, think about this. If the probability that the sum is more than 8 was 10 out of 36, in other words, 10 of the outcomes were greater than 8 of the 36, how many of the outcomes would be less than or equal to 8? Well, that just ends up being the opposite of what this is. So if 10 of them were greater than 8, 10 of the 36, that must mean 26 out of the 36 are less than or equal to 8. Which we can reduce to 13 out of 18. So you see, these two probabilities have to add up to 1. 10 out of 36 plus 26 out of 36 would be 36 out of 36 for all of the outcomes. We call this probability the complement. The complement event. So the complement event is simply the opposite of what you're trying to find. And we can use some notation here. To say this. The probability that event A occurs plus the probability that event A does not occur. So see this A with the little bar above? This means the probability that A did not happen. So the probability that A happens plus the probability that A does not happen will always have to equal 1. In our example, the probability that the sum was greater than 8, 10 out of 36, plus the probability that the sum is less than or equal to 8, 26 out of 36, these two probabilities add to 1. Another example might be the probability that it rains today. So if event A was the probability that it rains today, it makes sense that the probability that it rains today plus the probability that it doesn't rain today will obviously be 1 or 100%. It's either going to rain or it's not going to rain. So if we were asked to find the probability of an event occurring, sometimes it's easier to find the probability that it doesn't occur and simply go 1 minus that probability. Let me show you how that would work. Say I wanted to find the probability that I do not get a king. So when I draw a card out of the deck, I don't want a king. What would be that probability? Well, I could simply find the probability of getting a king. Since I know there's 4 kings in that deck of 52. And so the probability of not getting a king, king with the bar on top, that means not getting a king, well, would be 1 subtract the probability of getting a king. Getting common denominators here, so that I can do this subtraction, leaves 48 out of 52, which we can reduce to 12 out of 13. So you see, sometimes to find the probability of not getting a king, if we find the complement, the opposite event, which was 4 to 52, then I go 1 minus 4 to that 52, and I can get the probability that I was asked for in the first place.